Hello. Okay. Good morning, everyone. So I posted up the midterm announcements to tell you what to focus, what not to focus. Right. We need to focus on the conic section, the faces. Yeah. I put in the Moodle. Yeah, already. I think you should get an email after I posted the announcement. Yeah. The email notification. So no need to worry about those Photoline stuff. Yeah. Directrix, focus. Okay. Those will be too much to memorize. Yeah. Okay. So let's recall what we did. For Taylor series, right? We will do up to how to find Taylor series, but we'll examine on the estimation part. Okay. Later we will go through again. Okay. So let's recall what we did last time. Okay. So we learned that 1 over 1 minus x is the power series of 1 over 1 minus x is the sum of n power with coefficient 1. Okay, so this is the most basic power series we learn, right? With the radius convergence of convergence is what's the radius of convergence? Is 1. Okay. So how we find this? This is by the geometric series. Or sum to infinity formula, right? Okay. So the second power series we run is e to the power x. Okay. And we somehow use ODE to solve. We don't have ODE in the exam. Yeah, don't worry. So what's this here? Still, you have this power of x, right? Yeah, but what's the coefficient here? 1 over n factorial. Okay. So you have 1 over factorial n factorial in front of the power of n. Okay. So this is the second thing we found by ODE method. If you don't know about ODE method, it's fine. It won't be tested. But the end result is important. We know that the power series of e to the power x. Okay, and then we introduce this Taylor series. Okay, so somehow people are curious why we can express a continuous function in terms of power series. Okay. So later people found that actually the coefficient represent the n derivative of the function. Okay. So what this coefficient means is you evaluate. Okay, so let me write more stuff here. So what are these power series? So these are special power series, right? So these are power series representation of f. Okay, meaning what? They are centered at x equal to 0. Okay, So now we want to look at Taylor series centered at s equals 0. Or another term for this is Maclaurin series. So if you ask to find Maclaurin series, it's just Taylor series centered at 0. Okay. So Taylor series centered at 0 is what? So the first term is f evaluated at 0. Okay. Plus, okay, first derivative of x evaluated at 0 divided by n factorial. In this case is 1 times x plus second derivative evaluated at 0 divided by 2 factorial times x squared and so on. Okay. So always people tend to make mistake in Taylor series. They just compute n derivative. They don't divide it by n factorial. Okay. So you need to remember that you need to divide by n factorial each term. Okay. How you remember? You just remember the power series of e to the x. Okay. You remember this. Then you will know that you need to put n factorial in. Okay. People tend to forget this n factorial. They just computed the derivative. Okay, so be careful. Okay, so how about the most general Taylor series? Okay, so let's see what's the formula for Taylor series centered at anywhere. Okay, centered equals to A. Okay, so what you do, you just compute your fx at A. Okay, and then compute your n derivative at A. Okay, and multiply by the factor x minus A, and then also power of it. Okay, depend on which term you are at. By now, you should be familiar with this translation, right? Okay, if you want to move the center, you just move your x or y by minus the point. Okay? Okay. 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 Sure. So let's do, okay, let's go through theory first, then we will see example. Okay, so the n degree Taylor polynomial of f at a is the finite sum from 0 to n. Okay. Finite sum from 0 to n of what? Of the n, the k derivative at a divided by k factorial times the factor of x minus a, the power of k. Okay, so n degree Taylor polynomial means you stop at the n partial sum. Okay. So you can see that because this Taylor polynomial converge within the radius of convergence. So every time you add, right, you can imagine you get closer and closer to the function itself. Make sense? Okay. So fx, okay, which is the function, is the sum of Taylor series if fx equals to you take the limit of your partial sum, which means you take the infinite series. Make sense? Okay, so I can write here, this is equals to the infinite series. Right, if it converges, then the power series representation equals to the actual function. Okay, so of course, if you stop at any n, okay, there is some difference between the actual function. Okay, we call it a remainder. Okay, we call the remainder of the Taylor series Rn is you take fx, take a function minus the n degree of Taylor polynomial. Make sense? Okay. Okay. Okay, so this is an example. What's this example here? What's this example? Uh, I don't know why. Okay, I see already. So this is the example. So here. Okay, let's say we want to write EX in terms of power series. Just now we already write out, right? So what's EX? EX equals to 1 plus x squared over 2 factorial plus s cubed over 3 factorial and so on. Okay, this is the most classic one. Okay, if you can memorize now. Okay? So every n power of x come with a coefficient 1 over n factorial. Okay, so this is exactly what I said last time. Okay, so let's look at T1. Okay, where is T1? Okay, in this case, what is T1? What is the first degree polynomial of this case? Huh? Which one is T1? Huh? 1, right? Okay, so this is T1. Okay, first degree of polynomial. What is T2? Huh? 1 plus x. Good. So T2 is 1 plus x. What is T3? You add up to the third term. Okay, so this is T3. Okay, so what happened here? Okay, so where's T1? Okay, so this terms here, okay, you can see that what happened here. This power series is centered at 0. Sure, okay, at 0. Okay. So what is T1? T1 is 1. Why it draws like this? I think this T1 should be something like this, right? Huh? T1 is this. Let me see. Oh, okay. So yeah. So you can see that this index here, right? Index here, actually we start with 0. Okay. So we include the constant term in every degree. Okay. So in this case here, we need to include all the. Okay, let me write down. So what is T1? T1 is sum from k equals 0 to 1 of let me see, f a over a factorial times x minus a to k, which is what? Which is f0 a of 0 factorial times x minus a to 0 plus f1 of a factorial, which is 1 factorial times x minus a to 1. Okay, so you're right. So we need to include constant term every time, right? Okay, so meaning we need to extend our T1, T2, and T3. Okay. So every degree we add the constant term. I think the constant term will correspond to the 0 degree. Okay, if you like, we can add the T0 term. T0 is the constant of the Taylor series. Okay. Okay. So in this case, this picture make more sense. So T1 is 1 plus x. Okay. What is the line 1 plus x? Y equals to 1 plus x is y equals to x shifted up by 1. Okay. So this is the line. Okay, so this is the line. So you have y equals to x and then shifted up by 1. So T1 is here. Okay. And then T2, what happened? You add x squared term into this line. Okay. This line somehow bend, right? Bend. This is the green one, T2. Okay. After you add the extra x squared term, it bends. Hello. Okay. And then how about you add an extra, hello, x cube goes on. Okay. X cube goes on. Hello. No, right? Hello. Hello. Okay. If you add the extra x cubed term, right? Okay, what happened? You can see the blue line, right? The blue line. Do you remember what's the basic shape of x cubed? Yeah, right. Okay. So somehow the term get affected by this negative part. So it's still going down. Okay. So you can see that this blue line here bend down after 0. Okay. X equals 0, t cubed. And then you can keep going x4. Okay. Maybe later it go back again. And then go down again. Go back again. Go down again. Right? Because even and between even and odd, the shape. Right? Yeah. Hello. Okay. So okay. So you can see that. What can you see? What can you see? Okay, there's one thing to see here. There's actually one thing to see here. EX, right? Remember the power series, right? The power series converge everywhere. Okay, the power series converge everywhere. Can you see that this T1, T2, T3, right? Getting closer and closer to the pink line. I mean, it matches more and more with the pink line. Can you see it? So you see, for T1, right, it agree with pink color around here. So let me, around here maybe. Okay, let me use another, what color? Maybe use the red one. Okay, around here. Okay, so now I want you to keep in mind, we are estimating the pink line, y equals to e to the power x. Okay, let's start from T1. So T1 agree about that radius. Okay, and then what happened to T2? T2 is the green curve, right? Okay, so green curve here increase the matching. So around here, okay, here, and about maybe about here. Okay, so here is T1, T2, okay, and then T3. How about T3? T3 is the hello. Oh, listen. testing， testing， 没有很大声。Testing. Okay, thank you. Hello. Okay, good. So you can see that this T3 here, right? T3. So if you compare T3, the blue line, okay, with the pink line, so I agree about somewhere here, a bit, little bit, increase just a little bit, okay. So if you do more and more and more, then you can keep approaching your pink line. Okay, so if you take your y, your function, okay, your function y, which is this pink curve here, and then you take away t1, okay, so this is your remainder. Can you see the remainder? Okay, so the remainder is much bigger, right? Okay, compare you take the x t2 one, t2 is the green one, okay, and then you also can take the remainder and take the difference. So how are they different? Okay, yeah, okay. So this theorem here that you don't need to worry about, but I would mention it for the complete of this theorem. Yeah, the theory here. Okay, if your function can be write as the n degree of polynomial plus the remainder, okay, and the limit of your remainder go to 0 when you take n equals to infinity. For x within the radius of convergence, then this f is equal to the sum within the interval of convergence. Okay. Make sense or not, this sentence? You don't know why it's okay, but makes sense is enough. It makes sense. How you minus your original function. Okay, the series. How you minus your original function.
X minus.
Why not? It's just a finite thing, right? Tn is a finite polynomial. So you just take one function minus a finite term of polynomial. You get another function. Yeah. How do I know the difference? Okay. Let me show you. So for example, right? Okay. So we look at Ex equals to T1x plus R1x, correct? Okay. So what is T1x just now we mentioned? It's just 1 plus x plus the junk. Okay. So in this case here, what? R1x is equals to Ex equal minus 1 plus, 1 minus x. Right? Okay. So R1 is this. Okay. But you want to take limit of Rn, right? So you need to figure out what is R2, what is R3, and then write a sequence out. And then you take the limit. Right. So what is R2? R2 is 1 minus x minus 1 minus x squared over 2 factorial. And then so on. So kind of hard to write the formula, right? I'm not sure, not on top of my head how to write the sequence formula here, but you need to look at this sequence here converge to 0. This is the part that you need. Okay, make sense? I think it's just series. Yeah. But yeah. I mean, this. Okay. I mean, I can. So this is the sum of n from 0 to infinity of Ex minus f to the n of in this case 0 over n factorial times x. Yeah, so then you need to look at this partial sum here and then show that this series is converging to 0. Is it? I mean, this sum here is converging to 0. Yeah. N equals to infinity. But I mean, it's hard. It's a hard question. It's hard for this case. Usually it's hard. Usually. Okay? Usually it's hard. So next part is we produce a bound for our Taylor series. Okay? Sorry, the remainder. Okay? So how do we bound our remainder? Let's say we can bound our n derivative by a number m, a constant, okay, within some range. Okay, within some range. Then the remainder is just the constant divided by n plus 1 factorial times the factor of x minus a. Okay, this is very useful. Let's not worry about this. Okay, I just mentioned this for the sake of the theory. And then I will provide solution for this example here. You can study it. But I think our main focus today is to continue to practice how to find Taylor series. Okay, so let's do one example. Okay, we'll continue to practice how to find Taylor series. So now let's try and find the Maclaurin series for x, sine x, and prove that it represents, okay, this part maybe no need because we need the Taylor stuff. But I will still put on the solution if you're interested. So let's try and find the Maclaurin series, right? Or maybe we also find, can we find? Okay, let's do this first. So what's Maclaurin series? It's a Taylor series centered at x equals to 0. Okay. So what's the formula? So the formula is fx equals to the sum of n equals 0 to infinity of f to the n derivative evaluated at 0 divided by n factorial times x to the power n. Hey, by the way, have you guys checked the formula sheet? Okay, already. Okay. Familiarize yourself with that formula sheet. Okay, so what do we need to compute? Okay, we need to compute n derivative and evaluated at 0. Okay, so let's do them one by one. So fx is just sine x in this case. Okay, what is the first derivative of x? Cos x. Second derivative, minus sine x. Third derivative, minus cos x. And then fourth derivative, and then which is sine x. Okay, so you can see that we have a cycle here. Right, sine x, cos x, minus sine x, minus cos x. Go back to sine x again. Okay, and then you can repeat this cycle. And so you see a pattern here. So we need to not only compute the n derivatives, we need to evaluate them at 0. Okay, so what do we get? So f0 is just 0. Okay, f prime 0 is 1. F prime prime 0 is 0. Derivative evaluated at 0 is minus 1. And then 0. Okay, so you can see this pattern popping up. 0, 1, 0, minus 1, 0, and then 1, 0, minus 1, 0. Okay, because the n derivative also have the same pattern. Okay, so what do we do here? So sine x is equals to 0 plus 1 over 1 factorial x, okay, plus 0, right, plus minus 1 over, remember the n factorial, 3 factorial times s cubed, plus 0, plus, and then you can repeat 5 factorial, and then plus 1 over minus 1 over 7 factorial x cubed, and so on. Okay, so you can, what can you see here? The even term disappeared. Okay, only the odd degree term stay. Okay, you know what's the even function and odd function? You guys learned before. Okay, so sine x is a odd function. Okay, so you can see that only odd term appear. Okay, yeah, so only odd term appear. Okay, this really tells you some things. Okay, what? Okay, so for example, cos is a even function. Okay, if you go there and try and compute the power series, only the even degree term stay. Okay, the odd term disappears. You can try and compute. Okay. All right. So can you write a formula for this sum here? Can you try and write a formula for this sum here? Hi. Okay, minus 1 to the power n, and then? Okay, sure, that one, sure. So you only left with the odd degree. Okay, 2n plus 1 represent all the odd numbers. How about the denominator? also 2n plus 1 factorial. Okay, so one thing you need to know here is how you represent the odd number, okay, using n. So we write down a function in terms of power series. Okay, remember when we write this down, we need to make sure that it makes sense within the radius of convergence. Okay, so what's the radius of convergence here? Huh? How to compute? How to compute radius of convergence? Huh? What test do you use? Okay, so you use ratio test to determine the radius of convergence. Okay, so let's try a ratio test. Factorial is 2n plus 3, plus 3, right? Plus 3 over x to the 2n plus 1. Okay, so we want to make sure this number here less than 1, right? Okay, so within the modulus, we can really just get rid of our minus 1. Okay, so if you cancel the factorial, what do you left? You left with n plus 3, 2n plus 2, and then what do you left with here? X squared is less than 1. Correct? Okay, so the bottom part, okay, if you can't see that it converges to 0, can you see that they converge to 0? Is it easy to see? Not easy to see. It's not 0, right? It's not 0, so yeah, so what's that? Did I do something wrong or not? No, right? Yeah, okay, so what is that? So what's that, the limit there? Combine the term first. We get 4n plus 6n plus 6. Zero, right? Isn't it? Okay, 0. So what does it mean by 0 times every x less than 1? Huh? What's 0? What's 0? Okay, let me write down first. Let me write out this equation here. 0 times any x is less than 1. So what does this imply? Huh? What does this imply? Hmm? Huh? Always 0. Okay, 0 is always less than 1, right? So no matter what x you put in, you just get 0. Okay, so it is true for any x. Okay, so the radius of convergence is what? Infinity. Okay, any point. Okay. Or if you like, remember that this limit here is what we call the what? Here. Okay, let me recall another fact. Here without x is what we call what? The thing that we call L. Correct, very good. Good memory. Okay, this is L. So if this is L, our R is equal to 1 over L. And then we define 1 over 0 to be infinity in this case. Okay, don't ask me why 1 over 0 defined. In this case only, we say it is infinity. We just define it. Okay, for this case only. Okay, it usually is not usually undefined. Only in this case, because we have this reasoning here, because we can put any x into this inequality and then everywhere it converges. So we just say this is infinity. Okay, so depend on context one. Usually 1/0 doesn't exist. Okay, so this is the sine x. Let's show you another technique here. So Maclaurin series for cos x. Okay. So what's the strategy you use? So let's talk about strategy first. What to do if you want to find Maclaurin series for cos x? Maclaurin series is a Taylor series at s equal to 0. Okay. And then what do? You need to compute all the n derivative and then evaluate it at 0. Okay, and then use the formula. But we also can use the term by term differentiation here. Okay, so let's see what to do here. So, okay, so first you use Taylor's formula. Okay. So second, I want to use the power series representation term by term differentiation. Do you still remember the theorem, term by term differentiation? If the power series converges at a given radius, okay. If when you differentiate the function, is equivalent to differentiating every term in your power series. Remember? Okay. So we're going to use this. So what's cos x? Okay, we need to make advantage of what we have before. Okay, cos x is the derivative of. Good morning. So cos x is equals to the derivative of sine x. Okay, but sine x we know how to express in terms of power series as mentioned. Or we know the Taylor series already. Right, we just found it. Which is the odd, the sum of odd factorial n plus 1 or n? N, correct. So minus 1 to the power n times x to the power 2n plus 1. Okay. So this is true only when the radius is everywhere. Okay, so it's true everywhere. Okay, so this is true everywhere. So very safe. So you want to differentiate term by term. What do you get? So you can bring the differentiation in. You cannot just simply swap this sign, right? So this is only true because of our theorem. Okay. So I differentiate this. What you get should be just minus 1 to the power n over 2n factorial times x to the 2. And the radius of convergence still are infinity. Right. Okay, so what you can see here, you just left with even term. Okay, this is what I said just now earlier ago. Okay, so cos is an even function. Okay, so you left with even function. Sine is an odd function. Okay, make sense? This example here. Okay, so if you can use this term by term differentiation, sometimes you will make your life easier. If the question requests you to use Taylor formula, then you should use Taylor formula. Okay, so how about next? You want to find Maclaurin series of x cos x. So what do? You just multiply x to the power series of cos x. Okay, does this affect the radius of conversion or not? No, right? Okay, because x is already a polynomial. Okay. So let's conclude this. X cos x is just x multiply the power series of cos x. It doesn't affect the radius of convergence when you multiply polynomial. Okay. Right. Let's do this. Okay, let's do what? Let me see. Recess. How about do the last hardest one? Then we'll take a break. Find the Maclaurin series for 1 plus x to the power k. Okay, to the power k. This one is some power k. Okay, and show that it is convergent for the x within 1. Okay, radius of convergence is 1. So Maclaurin series centered at 0. Okay, I'll let you try this first, see if you can figure out anything. Let you try. Why you got answer? Oh, hey, very clever, you. Good, very good. I think very good. From the bottom of my heart. So please bring out your formula first. Okay, bring out your formula first. Let me write something useful for you. Okay, one by one call out name. Start from Ling Tianyang. I know Ling Tianyang. What's your name? Huh? Huh? Minh Khai. Last 3 numbers. Then Okay. Okay, without, okay. Next. Last three number, okay.
700.
X. Living way. Nine four four. Okay, Five four five four. Okay, okay. Speed number. Dán thì wrong. Zero. Zero. Dán thì wrong. No, không. Không. Next. Next. In front of Tom. Last three number. They hai năm năm lúc được. They win. And then next. Hai three CST. No CST. What? Hai three. Five nine three. All three. Your full. Okay. Sân how we how we do. Okay, yeah. How about you? Oh, okay. Sân how we you last time. 094. It's okay. Oh, parent. Okay. Hey, last three digits or parent. 954. 954. Okay. Hello. Okay, so let's continue first. Did you manage to compute all the derivatives? Okay. So what is fx? Fx is 1 plus x to the power k, and then f prime x is just k times 1 plus x times k minus 1. F prime x is just k times k minus 1, 1 plus x, so k plus k minus 2. You keep dropping out the power. Okay, and then for the n term is k times k minus 1, k minus 2, k minus n plus 1, 1 plus x to the power k minus n. Okay, so what do you do if you substitute x equals 0? You can see that you just get f0 is 1, f prime 0 is just k, and then what you get is just the coefficient in front of your power of x, power of 1 plus x. Okay. So you need to plug this into your formula. Okay. So what is the Fn0 term? It's just k times k minus 1, k minus 2, dot, 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 k minus n plus 1. Does everyone got this? Or you don't know how to figure out the n formula? Can everyone get this? If you haven't formulated the n formula, can you see why this is true here? Can you see why is this true? Why is this minus n plus 1 the last term? Okay, you can see from all the third term, second term, and the first term. Okay, so the last term is minus 3 plus 1, which is 2. And then the second last is minus 2 plus 1, which is minus 1, and so on. Okay, this is how we deduce the formula. Okay, so what's the Taylor's formula here? So this is 1 plus kx plus k times k minus 1, right? K times k minus 1 over 2 factorial x squared plus k times k minus 1, k minus 2, 3 factorial x cubed, and so on. So you might wonder, do you have a formula for your coefficient, right? Okay, so this is the hint I gave here. What is this fraction here? These are the generalized binomial coefficient. Okay, so why I call it a generalized binomial coefficient? Because this k here, right, you can really put anything here, any number. Because binomial coefficients, usually we only introduce for positive integer, right? Because you only then you can pick and choose object. But here you can work for anything. Okay, so we can write this as the sum of n equals to 0 to infinity of k choose n x to the power n. Okay, the formula is still the same, just that the number you put in is different into the binomial coefficient. Okay, so what's the next thing you want to do? You want to check whether this has a radius of, what's the radius of convergence? Okay, so by ratio test, you need to make sure the an plus 1 over an term, okay, with modulus is limiting to number that is less than 1. Okay. So what's this an plus 1 and an term here? Okay, so an plus 1, you will have term multiply up to k minus this one. Okay, let's write down the an term first, right? So an term is already quite complicated. So the an term is this multiplied by n factorial times x to. Is this right? Okay. So what's an plus n plus 1 term? So you need to sub n to n plus 1. Okay. So the last term here will become k minus n minus 1. So plus 1. So you get k minus n. Okay. So you will have one extra term here up to k minus n. Okay. Then factorial, you just put n plus 1 factorial, and then x to the power n plus 1. Okay. So what do you left? You left with this huge thing, this cancel, and then this can, that is less than 1. So this implies that k n over n plus 1, the x is less than 1. Okay, so what's this? What's this? What's this? Okay. Now, can you get rid of modulus? Can you get rid of modulus? Can? Why? Why? K positive integer, okay, sure. How about k minus n? Sure, k positive integer. How about k minus n? K is always greater than n. K is constant now. We already fixed the k. Okay, but this n is keep growing. Okay. Huh? Yeah, the limit is 1, but I want to talk about the negativity. K minus n, at some point you will reach negative. Right? Because n is keep growing. Okay. So really here we need to keep our modulus on. We cannot simply throw away our modulus. Okay. But again, like Yishun say, how to evaluate this limit here? It is k over n minus 1 over 1 plus 1 over n. Okay, so I divide n on both sides, again, top and bottom. So what's this here? So this limit to minus 1 after taking modulus is just 1. Okay, so you can see that this modulus is really doing some job here. And so the radius of convergence is 1. Again, radius of convergence is 1. So this implies that the radius of convergence is 1. If you want to check the interval of convergence, right, what do you need to do? You need to check the endpoint. Okay, for this question, it's quite complicated. Depend on what k, the interval of convergence will change, and very hard. So it's fine. Okay, let's take a break until 9:15. So have you guys done any review question, tutorial questions? Do you have any question you want us to go through together in the class before the exam?
Also, this not inside the exam.
What do you mean?
This topic.
Inside? Inside the series. Yeah, just that we don't test the estimation of the remainder. Yeah. Okay. I will provide solution. You can have a look. Okay. Later we'll do a few questions together. Yeah. Tips. Huh? What do you say? Luckily you can. You should always have. Huh? Huh? I don't think so. Yeah, rest until 9:15. Okay, let's continue taking attendance. 等一下再打。不练写什么？不紧，不要怕，我罩你。
我怕你哦，
你怕什么？
找我名呢？确定吗？你确定你想的名跟我的名字一样吗？确定吗
？OK，
就是这个问题，他到底是在干什么呀？Prove that it
这个就是我们没有 cover 的地方，就是其实是跟着这一题啊，跟着这个 theorem，因为他讲如果这个对，它就 equal，他那个说 prove that 它是 equal 对吗 ？prove that 它 represent 就是 equal 咯，所以他要 prove that 这个 limit 去零。如果要 prove 这个 limit 去零，就要用到这个 inequality。
哦，
对，这个没有 cover，
但是
但是我会给答案，你可以看一下。
我意思是 prove 这个 series represent。
啊，
不然的话真的很奇怪，sin x represent sin x。
所以这个 it 是指这个 Maclaurin series。How series represent？
这个
我会点的，对。
OK。
等下我给你们做题的时候，
你讲，
好，
你讲你广告你
那个，这个我没有做过这个题目，这个也没有。
seriously
啊，破财要不要 sponsor 我？
我这里杀了
两
你，
个列，我之前记得。
这是
它
protector
就是
screen
它
还是 screen？
没有，我的 brother screen 裂掉，拆掉。
然后又再裂掉，
呀，
哇 ，jackpot 哦，这个 it's OK，WWDC 要出了，
对，
那个力给我了，
做错了，我没有用
哇，
到
真是顺哦，
这个120赫是吧？
我们
这个很早期哦，不确定哦，
一代 Pro
我们一直上更新。啊，对，对呀，对，没有错。你一路来不是拿那个吗？OK，明白。对，哇，你又可以抄又可以想，你很快哦，厉害，可以，厉害。
刚刚你讲，你看你在 group，然后你讲你在 Google，然后说你讲没有考 connect session 咩？
有啊，
看到没有？
有啊，
有，老师，
你开一下，
我开一下，
你开一下，有吧？
8哪8了，
有，我只是特地吧，有。
客气哦你，很客气。announcements 为了那 announcements 最新的吗？midterm
读一下。
up to today 吗？哦，没有啊，
没有，你读太快了。
那里，那个这。Oh, curve related formula. Our OK， so it's a quadratic surface of
就是那些啊，那个也讲啊，
哦，那个啊
也讲啊，
那个你出我也是我也是送你哦，我给啥的2季哦，怎么办？你要买新的吗？
不然买啦，周末。
你要买一样大理啊？哇，这个贵哦。
贵哦，你这个多
如果
少钱？
再坏我就不能买了。
那时候你在欧洲买是澳洲
澳洲买
这个便宜还是那个的呀？
一样，
这是
差不多，
第一代啊，
除非你退税啊。就是好像是，
第一代
对，
啊
这，是第一次。
这第一代 Pro，第一代 Pro 是很大的。
不错啊，这样就有2粒了吗？
可是这个裂的哦，
裂的一点不了，
还可以用，还可以用。幸好还没有，好像有很。
这个是 screen screen 啊，不是 protector，
你没有看过谁裂是不是？
了，这是。
我没有跌，我换 back 罢了。
那你压
做到还是怎样？我不懂啊。
那你的 bag 真的是，
那你知道？
这样买好一点的 bag。
我跟你讲，这个很多，你看这个很早就裂了，
What the fuck？
这个好像1年前
新机的啊，
没有，它壳很越大力越软。
它有一个那个 weakest point 在这边。
有一个 brand 啊，什么 brand？
还有一个 weakest
直接裂一个。
王吉吉，你坐在哪里？
我说
你刚来啊？
没有啊，我去上厕所呢。
哦，应该是上厕所哦。OK，这样吗
211去220992。
OK，可以，好。
但是
好吧，
周末你跟我朋友讲，我们考试1个小时不了啊？
我跟你讲 quiz
啊
我讲 quiz，
我讲 quiz 啊
可，能讲错我讲 quiz。
他跟我讲考1个小时半，我要考
quiz。没有啊，我昨天跟那个明凯我明凯讲2个小时啊。
吓死我！
你跟谁是你朋友？那个思雨啊？
啊，
哦，
他跟
我是讲 quiz，
他跟我讲你考试1个小时不了啊？是咩？我看母的不是2个小时咩？
quiz，
吓到一个。
吓到一下，差点睡不着。
不是这个 factorize 我不能讲 factorize 咩？
然后
就他答案不一样，
答案不一样咩？
我就问你嘛，因为他
你看，没有，你都还没有算完，你这个是什么来的？你看，你这个你都还没有写完，这都不是那个Taylor series 或者 Power series，对不对？
不是，这是那个
你还有一个 extra s 减1跑出来哦，我要写成那种 s 减 a to the power n 的形式哦，你还没有做完，
A to the power of 什么？
你
你要写成那
成
种 xn+1那种是吧？
要写成，我开课的时候讲这个，要写成这个形式哦，这种形式哦，你这边又有 Sn 又有 s 减1，所以怎样呢？你懂什么意思吗？还没有结束，
哦，
你还没有结束，
就我这边，
嗯
可是我沉浸的话，等一下就不是变成两个那个什么吗？
嗯，什么意思？
我沉浸的话，我就变成两个萨码嘛。
嗯，明白，可以。所以你要怎样写成一个？呀，所以你要写成这样写成一个。所以你要怎样写成一个？
What the fuck？
嗯，
对，
对呀，你还没有完，这个东西还不是一个，还不是一个，它是一个 Power Series，但是还不是一个 Taylor series。
因为我看别人哦，他
呀
他是直接这样子做啊，是这样子 factorize 的。
对对对，
然后他直接这样子做就很快吧？
因为它剩下 constant 嘛，然后这个 Power Series representation 一出来就是它了。
对啊，
对
他这样子做，
对啊，这样子做的话，
可是我答案还是错啊。
什么意思？
他答案这里是1减1/2哦，
我要答案错啊，
我不懂啊，他这边是写1减
我
什么什么，
没有算过。
他这个答案是减1/2，
你是说那个一 combine with 它 constant 过后，不是那个1/2？
不是，
真的？
我不懂，
你不懂？
我不确定，
你不确
我
定？
不确定。
看一下，你怎么没有3/2的？你的3呢？
3/2，
对吗？
有开到
哎，
电
不是，没有看到，开了。你下一步是什么？你这个下一步呢
没有，我在这个人。
？What？这样快？你确定？你除2对 make sense？可是你要放减，所以你已经知道1/s 加1这样 expand 了，是不是？是哈。对啊，你的 constant term 不是1减3/4咩？啊
2/3咩？
对呀，不是咩？你如果这边全部放0的话，你的 constant 不是1减3/2咩？对吧？你 n 等于0的话，这边不是第一个 term 是3/2，
哦，
那你就会 combine 哦。然后这个3是从1开始啊。
就变1/2哦。
怎么？通常我们会 combine constant term，不会有2个 constant 合在一起，就是一样 degree 的东西，我们通常会加在一起。
哦，
我们不会让它 float 在同一个 expression。
这不明白。
对吗？怎么了？怎么？
没有，我不明白，就是
不明白什么？这个为什么算不到？这应该可以算得到。还有什么
不要紧啊，这个不要紧，这个不要
？OK
紧。
啊，这个不用紧。会，不要怕，
I'm worried, you know？
不要太 worry
我不懂，不懂哦。
啊。Thank you。昨天
可以分享一下吗？
啊，昨天
不急。
什么不懂？哪里不懂？
因为我就是不明白，它会变成这样子，
怎样变怎样哦？
就你刚刚讲什么 constant 什么 a 的，
没有啊，没有，我只是这一整串东西不是就是等于你全部写出来吗？你全部写出来的时候，你肯定有2/3在前面的嘛。
啊，
然后我只是一减掉它罢了，就这样罢了。有什么问题？什么问题？
对，就剩下减1/2的
constant。有什么问题？你不要看这个，你把全部东西写出来。
什么叫做把全部东西写出来？
I mean 就写成这样子的，
一个 time 一个 time
一个 take 然后这样。
哦，好，
哪个问题啊？
你就可以看到了，
这个练习一点，
你可以看到，你看得到了，
完了，
你看得到，有吗？
你觉得我需要做吗？
这么不需要做啊？
不是，如果你在班上没有教的话，但是那个 notes 这个就那个这个里面有啊，然后你 tutorial 是有给我们的考试出，就比如讲那个 recursion 那个2.19199嘛，你没有马上没有教嘛，但是这里面有，然后你给 tutorial 是有，它会出门考试。可是我们只需要读你班上教的东西了。
那个是我有一点故意 skip 掉了，因为觉得你们好像之前去看过了，我也不想特地讲
啊，什么我们读到完
啊。我是可以讲不要读了，但是我讲
其实不会出啊，老师不会出，你
不会出啊，不会出了，不会出。
哦，那你教你的，我们才需要读你教的东西。
理应是这样，对，理应是这样。
但是
跟我讲你要回去看的东西。
如果我来重复做完全部 lecture test 里面的问题，要看那 solution。我觉得过了没，还是我要做那个 extra tutorial。
不要看懂哦。
我觉得如果你够聪明的话，你可以只做 lecture 那里面的题目。
我们这个聪明。
就是你可以肯定是可以的。我可以告诉你，你只要会玩 lecture note 里面的 skill， 你可以灵活运用的话，你不需要靠题目来帮助你讲理解，你就可以了。
只有读你的 note 就可以了，所以你平时 send 去那个母的那个就可以了。
对，那个 skill 啊，不是题型啊，不是题型 skill 啊，不是题型。你如果只会题型，你就会记错。OK， 我之前班有一个 AIT 啊，sorry， 我之前班有一个 AIT， 他没有怎么做练习啊，但是他在我班拿差不多最高分，他只进来听我讲东西吧，他手没有什么动啊，混蛋啊 ，OK， 再看，不是我的 quiz 啊，我的 quiz 上网找不到啊。找不到，我让你去找，你都找不到。啊 ？Open quiz 啊 ？OK。因为我们quiz你在看，你就给我当我们比较重要的那个。Hello. Okay. Just briefly go through. This is the important Maclaurin series. If you want, you can check it. Find the derivative and then you can show this. And then the right hand side, the interval is the radius of convergence. Okay. Yeah, don't need to memorize. We already compute all of these except tangent, I think. Yeah. We already compute almost all of these. Tangent one I will put as a solution. Yeah. So in principle is for university or lecture, you just need to focus on what I teach, what I learn, what I taught here. Sorry, what I present in the lecture. Okay, so I mean for this kind of question, right, correct to error, no need to worry about this. But for the completeness, maybe you should at least read about it. I will give you the solution. Huh? Yeah. Sometimes I'm very hard, very worried when you ask this one got exam or that one got exam or because I don't want you to like if I say this one is not exam, don't appear the exam, then you straight away don't look at it. Okay, this will affect your understanding towards the topics. Okay, if I say it's not in the exam, but you at least should read it. Okay. You got read, huh? Okay, good. So at least just read through. Okay, just read through. This will help your understanding. Okay. If you throw it away, then your knowledge will miss a portion of it. Okay, just blank there. Okay. Sometimes the question is related. Okay, then you can have more stuff to imagine. Otherwise, you will what? One of the possibility also help you to understand what the question is asking. Okay, let's do some review question. Yeah, I give you some review question. You try. You. Hey, Sui Long, Sui Long. Okay. I still finding the question. Square root, and root, I thought the root 1/4, or like this.
N root is it?
And root.
N times.
Okay lah, we check two. Second one. Hey, the idea Jinghua gave me, what's the idea? The limit of modulus an equals to other number equal to c. Does it imply the limit of an goes to c as well? Right? You remember you asked me? In the in the sequence chapter, right? If you check that the absolute value goes to 0, the original sequence will go to 0. Then you say if the 0 changes to other number, does it still work? Yeah, I give that in your if the max class has need to reference you. AIT 宋金话. What? Why? Why? Go to confession. Yeah, second question is okay. So I'll let you spend about 20 minutes from now.
Solve the problem.
What?
I mean, we can't solve the problem yet.
What do you mean?
Symbol Lab say cannot solve the problem here.
Oh. Wait for you, ma. You are AI, right? So you produce a AI. It is her Terminator. Huh? Try first. Later I'll tell you. Liêu tình ý. You học chỉ có liêu này. Okay. Who's the one behind Wen Keng? Ming? Huh? Liu Jiaqing 080，可是有点像姚明啊，都是跟姚明同一个地区的。没有，开玩笑，问吧。Okay, behind 姚，behind 刘佳琪。哦，对。啊，用刘。What's your last 3 digit? 刘拼音啊，刘拼音。You Chinese or Malaysian? Huh? Are you Malaysian or Chinese? From China. Okay. Okay. Thank you. But you looks a bit like Malaysian. Okay, Long Ling Bo. Simple. Hey, do the question you know how to do first. Don't keep discussing because no time. You do the question you know how to do first, and then the one you cannot do, then discuss. Okay, because I think question 2 spent quite a long time. Okay. I think so. Is it? Yeah. I know you. Let me recall. Let's see. 江宏宇。哦。江宏宇精华。王雅美is it? 雅美啊。Later step for quiz, right? Later you step for quiz. Already. Don't worry. How about the one beside Yamei? Beside Yamei. Oh yeah. What's your name? Su Zhao Gui. CST 142. Okay, good. Thank you. How about you? Hong Jia. 126. 136. 136. Hong Jia Xuan. Okay. Ling Si Chen. Okay, how about after Ling Si Chen? Yeah. Wang Xilong. Oh, this is okay, Wang Xilong. Okay. How about beside Wang Xilong? Zhao Jinghan. Last 3 digit. Last 3 digit. What's your last 3 digit? Student ID. Huh? 098. Okay, Zhao Jinghan. Li Kang啊？子康。OK， 都子康。OK。有啊 ？078 连夜。OK。连夜。赵以轩。099。OK， good。OK， thank you。How's the progress? What? Hey, can I have some volunteer to do this question? Let me become a student. Which one? First one. What's harmonic test? Okay, I want someone to do the question 2 first. We leave the hardest one to the last. So let's do question 2 first. Done question 2. Is that what you want to try? Want to try? Let me see. Who is Tian Cai? Tell me in your class. Dunta. Vote Dunta. Not just one question. Got second one. Dunta can do or not? Why you hiding? What's the? Oh, I know. 方子好 and how I know you get full mark. I think you can do this question. Try. Come. Try. Wait, 可以 try. 可以。Hey, you get full mark in your quiz. I remember. Come, quick. Just question 2. This one, horizontal tangent. Wait, what? Quick. Come. Do. Come. Huh? 还没睡醒。林天阳 you want to try? Do question 2. Yeah, you try. Yeah, you try. Come and try. Yeah, you come and try. Yeah, so you explain to us what you did, and then we will see if there's anything wrong. Yeah, you just do on the spot, it's fine.
Not sure I will get it back on the.
It's fine. We all can check together. Never mind. Sure. No worries. Yeah, you just get this.
Oh no,
No, take this. They cannot hear.
Okay.
You explain what you did when you write.
First, I think.
Wait. First. Let's use this.
The first I think is to draw a picture of this. Yes. This coordinate. I mean the polar equation. Let me recall some knowledge. Yeah.
5 minutes. 5 minutes.
Okay. Sorry. Oh. Maybe I don't know.撤销。
Undo.
Yeah.
Or you want to change pen?
Yes, I
Change pen. You just then between these two.
Okay. Thank you. Yeah.
我觉得可以。Okay. Open to question. Open to question. If you have question, you just throw up to the speaker. Okay, I invite a speaker here.
Shit. Think I wrote something wrong.
Yeah, origin.
说好。不知道答案。我不知道答案对不对。
Oh, you just explain.
呃
Explain what you did.
What I did is first to draw a picture of this polar equation, and you will find the graph is symmetric, and know that the question is that has to find a horizontal tangent. So what we need to do is to find the expression of the dy d theta, and when you got this equation, and we just set it to 0, and we can get answer. But we should notice when not every answer will be the final answer. So this minus pi, we need to check. I feel I have to check the answer for the other two others. I mean the pi over 3 and 5 pi over 3. I just think that I don't need to check these two answers. I have that feeling, and yes, and when theta equals to a minus pi, yes, you will find that d theta is equal to 0, and I have that experience and the limit when theta approach to the minus pi, the limit is infinite. So the when x equal I mean the theta equals to minus pi, the actually it is the vertical tangent. So the final answer is pi over 3 and 5 pi over 3, and something. That's all.
I have a question.
Yeah.
So why you set your theta equals to pi over 3, pi over 3, and minus pi? Because they are like integer value of them satisfying the equation, right? So I mean, when you solve cos theta equals to half or minus 1, right?
Yeah.
You have infinitely many angle that satisfy the equation, right? So why you pick pi over 3, pi over 3, and minus pi?
I mean, I just consider the interval of from 0 to pi.
Okay, why is that enough?
I mean, actually, I don't consider the I mean the 周期，就是我不知道 yes period. So
okay, but minus pi is not in 0 and 2 pi.
Sorry, actually I want to mention is pi, not minus pi. Sorry. But I mean I can just okay, just change it to pi.
Okay.
The understand.
Okay.
Just mistake.
Okay. Thank you.
Understand.
Okay. Thank you.
Okay, thank you very much. Thank you, Tian Yang. Okay, almost correct. Very good. Okay, I think you have a potential to come to maths degree because you don't show everything. Okay, they like to skip step. Okay, so we like to skip step. So he says that I have a hunch that I don't need to check pi over 3 or 5 pi 5 pi over 3. Okay, this is not simply feeling, because this is what you can see from this diagram here. Okay, when it is pi over 3 and 5 pi over 3, I think it's around here. Okay, but really you should check it. Okay, you should check that dx over d theta at pi over 3, 5 pi over 3, say this is true, it is non-zero. Okay. Okay. So here, like what he said just now, you should really pick the angle within the I think in your textbook it calls the parameter interval. Okay, the parameter interval for your curve. So meaning starting from what angle this curve start repeating. Okay, this curve start repeating after 2 pi. Okay, so when you plot from 0 to 2 pi, you'll get the whole shape. And then after 2 pi, you'll keep continuing drawing this shape. Okay, so this is the interval, 0 to 2 pi. So this is the all the angle you need to list down to check this equation here. Okay, for example, in the assignment, not assignment, the quiz. Okay, the quiz, we really need all the integer answer, because the polar graph is not repeating, it's keep continuing. Okay, every point represent a different xy point in our plane. Okay, but in this case here, after 2 pi, you will represent the same xy point. Make sense? Yes or no? Okay, so this is the this shape can be drawn for interval 0 to 2 pi. Let me change this color to different shape. So after 2 pi, you repeat this shape. Okay. So for horizontal tangent, what do you need to do? Just recall again. You need to check that y d theta is 0, but dx d theta is not 0. Okay, dx d theta. So if you want to find vertical, you need to make sure dx over theta is 0, dy over theta is not 0. Okay. So dy d theta have two ways to compute. Either you write y in terms of theta first, or you use the formula. Okay. What's the formula? Can anyone recall? Can Yi Zhao recall or not? The formula of dy d theta in terms of r and theta. What's the formula you saw just now? dy over d theta is equals to dr over d theta times sine plus r cos theta. That's all? Yeah. Divide what? Okay, wait. Let me move this. Move this. Divided by what? dr d theta cos theta minus r sin theta. Okay. So depend on which one is easier. Huh? Oh, this one is dy dx. Okay, this one is dy dx. Okay, so depend which one is easier. Yeah, you compute the tangent at that point. Okay. Okay, let's go to question 3 first. Let's go to question 3. Okay. So last time we said that this is very hard to integrate. So what can we do? Okay. What can we do is okay, what's this? So this you should use what? You integrate until infinity, right? So you need to use improper integral. Okay, so this one very important, improper integral, especially when you are using the integral test. So I think if you use by heart, by part should be hard. So maybe you can use change of variable. Set equals to ln t. I think this is what I did. And then e to the y is equals to t. Okay. So when t equals to 1, y equals to 0, t equals to n, y is e to the power. Wait, let me see. Y is ln n. Okay. So let's do this. 0 to ln n. Okay. Dy is what? Dy is 1 over t dt. In this case, so dt is equals to t times dy dt. T is also e to the power y dy. So altogether we have dy over y. Right? Is that right? Does everyone follow? Does everyone follow? So I change this variable to y, okay, and then I introduce the change of variable of dt. Is that okay? So maybe I move it up, maybe clearer in this case. Okay. Follow? Okay. Okay. So how to differentiate this, integrate this? Okay. So we can learn we can use the technique. What's technique? The power series technique. Okay, power series technique easier because we just integrate polynomial, right? So because we are integrating from 0 to ln n, and then the power series of EY also converge everywhere. Okay, we can use this. We can use power series. So this one is what? 0 to ln n. Then power series of EY, still remember what's that? Is the sum of n equals to, okay, don't want to use n anymore, use m. Don't clash of y to the m over m factorial, right? And then we got the divide by 1 over y. Make sense? Okay, because this radius is everywhere. Okay, so it's so good. Okay, everywhere we can apply. In particular, in our integration domain. So what's this here? Okay, we can simplify our series here, which is m minus 1 over m factorial dy. Okay. If you are a little bit uneasy with this notation here, you can always split your sum out. Okay, so the first term is 1 over y. Okay, second term is 1. Third term is y over 2 factorial. And then y squared over 3 factorial, y cubed over 4 factorial, and then so on. Okay, but we have a theorem says that within the radius of convergence, we can integrate the infinite series term by term, right? Okay, so by theorem, we can integrate our series term by term. Okay, so what do we get? I think now it's easier, right? This integration here. Everything you know how to integrate, right? You get ln y plus y squared over 1 Sorry, this one should go away already. I'm integrating. So the 0 to ln n. And then plus y cube over 2 factorial, y4 over 3 factorial, and so on. Right? Okay. So what can you see? Does this converge, diverge, or not? Does this converge or diverge? Okay, so you can see that here, if you put ln n here, right? So ln n squared, ln n cubed, ln n 4. And then you take ln n to the n to infinity, you get infinity, right? Okay. How about the other one? 0. 0 on the y polynomial evaluated at 0, you all get 0. But what happened here? Here you need to take limit. Okay, you need to take limit again. Because ln go to negative infinity, right? When you approach 0. Okay, but you are minus the negative infinity. So infinity plus infinity is infinity. I do that a bit. Wake up. Okay, so you get infinity minus limit of n to, sorry, I should say limit y to 0 of ln y, okay, which is limit infinity minus infinity, which is, okay. Okay, so a bit over time. You want to finish the first question before we leave? Oh, you got me turn. Anyone want to leave or not? I mean, anyone want to stay or not? Sorry. You want to stay? Just 10 more minutes. It will finish. For those want to leave, leave. Okay, so let's do this question, these two questions here. Okay, so these two questions, which one is more doable? Which one is more doable? Number 2. How to do number 2? Compared to what? Compare to n. How you compare to n? Greater than n, you mean? Greater or equal to n? Is this right? Ah. Oh, okay. You mean like this? Like this? For what? Like this if you want to compare. This direction is wrong, right? The big stuff diverge. How you imply the small stuff diverge? N divided by 2. Still diverge, huh? N divided by 2. So you cannot bound above by something that diverge. Limit. What limit? Huh? Huh? Okay, so let's see. Can we rewrite this or not? This is 2 to the power 1 over n. Okay? Which is what? Which is, okay, this is not PhD. Okay? Huh? Do first one first. Let's try the first one. Anyone manage to do something? Try something? No. Okay, so it's a bit tricky here. Okay, so what we want to compare. Okay. You can compare with 1 over n. Okay. just play around with this power here. So what's this? If you can't see clearly what's this, you can do some change of variable where you get 2x minus 1 over x. But now x go to 0 instead of infinity. Okay, so in this case here, what's this? So what's the limit of this thing? It's the same as the limit above, but you will get 0 over 0. Okay, then you can use L'Hopital rule. Okay, so one thing you need to know that how you take differentiation of 2 to the power x. So how to take 2 to the power x? You actually get 2x dot ln 2 over 1. So if you wondering how to get this, right? So you can write 2x equals to e to the ln 2x. And then you can write e to the x times ln 2. And then you can differentiate. Okay, so what is this here? What's the limit here? This limit is what? Ln 2. Okay, ln 2 is should not equal to 0. Okay, so this is not equal to 0. Okay, which no, this is not equal to 0, but we are trying to use limit comparison test, right? Okay, this is not called limit comparison. This is called the yeah, right, correct. This is the limit comparison test. What's the limit comparison test again? Okay, so if L is the limit, if the limit is finite, okay, then the series converge or diverge together. And then if L equals 0, what happens? Okay, so if L equals to 0, if Vn converge, then An also converge. Okay, so 1 over n converge or diverge? Huh? Diverge. Why? Yes. So this 1 over n series. Okay, let me write it down at the bottom. And since the series of 1 over n diverges as harmonic series, L equals to ln 2, which is finite, not equal to 0, by limit comparison test. And the series diverge. They diverge together. Just okay, how about question 2? Huh? What do you mean? Bn, what's the limit comparison test? So let's recall here. Limit comparison test, you need to make sure An is greater or equal to 0, and then Bn is greater or equal to 0. And then you need to check the limit of these two. Do we need to take modulus? No need, right? Because both of them are already positive. So we need to check what is this L here. Okay. So if this, okay. Say we have this. Okay. If L is in between 0 and infinity, the series of An and the series of Bn diverge or converge together. So, and then if L equals to 0, and the series of Bn converges, then An, the series of An also converges. Okay, so this statement will be given in the formula sheet. Okay, first question. Okay, how about second question? You mean how I guess? Huh? How I guess? Or how you guess? So how you guess, you try something similar to this function that changing. Not necessary. Not necessary. But you want to compare to something that you know whether it converts or diverges. No need, no need. So using limit comparison test, right? There's no, you don't need to compare An and Bn. Only the what is that? Compare ordinary comparison test you need, right? Okay, limit comparison test you don't need. Okay, yeah, you just need to know the ratio of them. Okay, don't confuse, don't confuse. Okay, yeah, don't confuse. Okay, something like that. Yeah, just try only. I also don't know. I mean, at first you also don't know whether it's true. Just try. Okay, then it turns out the limit is finite. Good, done. Yeah, if it's 0, then bad. Too bad. Okay. How about the next one? Number 2. Divergent test. Divergent test. Okay, so how do you use divergent test? You want to show that the limit of n times square root 2 minus 1 is non-zero, right? Is this true? True. True, right? Okay, because this term is infinity. Infinity minus 1 is infinity. Okay, so this is non-zero because what? Because n times square root n square root 2 diverges. Okay, the sequence diverges. Okay, so by test of convergence, test of divergence, series diverge. Okay, any more questions before we break? Before we finish? Any question before we finish? Question? Others will see you in the exam hall. No question. So if within the weekend you still have questions when doing exercise, you just feel free to send me on Teams or email. And please be punctual at o'clock. Next Tuesday, LY3 second floor. Yeah. 8:30, but come at 8. We will enter hall and then arrange the seating, so on, so forth. Okay? Don't cheat, Don't cheat. Don't plan to cheat. All right, see you. Good luck. See you next Tuesday. Hey, Yame and Chen, can you go to 1A4448? Wait for me. A4448, my office. We'll take the quiz in my office.
我还有这个就做错了，为什么这样自己跟我这样说？因为我自己看资料。
我是不是还没有签？
我帮你点了，我帮你点。
帮我点了。
对，我帮你点。
这拿是减1，这2减1减4什么减1等于3。
你我想下都没有 check 他的 working。对呀。
我没有跟在 working 啊，
我知道。你现在要做模，你现在要做模。哦，你算到2个都是0。其实你其实可以 stop 在这个 step 啦。但是假设如果你还要继续算的话，
那有
其实你可以 stop 这个 step 了，因为我只要 check 它不是零，我要 check 它不是零，但是你已经 check 到它是零，就可以 stop。
假如我们两个是零的话，就是有可能是 point，也有可能是 particular value。
然后你讲这个有没有算错，是不是？
我觉得我应该算错。
那现在打算怎么？
这个我没有计算，我凭我的经验就是知道它是正无穷，因为
我知道，
因为之前题都
看一下啊，你应该没有算错吧？你都算到 point 出来了，对不对？
first part 是 minus one right？诶，right。
那0比0的话，你两个都是零，那你用卢比达试一下呀。卢比达试一下，卢比达法则。
没有啊，它不是零就零啊，它是
是吗？
不是，它是
这也是 cos 加1，这个也是 cos 加1，这两个就不这样。
约掉，那你这是？
就剩下的是这个是减3，就是减1啊。
这个。
是那个 tangent 是的，
可是你那个 dx d 西塔你怎么全都换成 cos 你怎么做到？不可能呀！我算出来这个 dx d 西塔肯定有3西塔在里面，你怎么全都换成 cos 西塔？这怎么可能？不可能呀
！dx d 啊在哪里
？dx西塔你肯定要么来算错了吧？你怎么可能全都是那个？
我存进去了哦。
不是，
可是你 differentiate
不可能。
OK，
这不可能，我不要这个。
条件我可不可以直接用 dy dx？ 因为只要 dy dx 等于0 ，means like 它只要 dy dx exist， 就是我的 d
因为这些是
不等于0。
是
就我们那个时候我们要找那个什么关道嘛，
对，
我要 dy，
对，
dy d theta 等于0，然后 given that dx d theta 等于0。但是我可不可以直接放 dy d theta， 我只要 dx， 然后你找到任何东西都是 d， 这个东西已经fulfill了。
可是如果你 dy d
只要 dy dx 它 exist 的话，就是讲这个 point 不会出生，
因为如果它是0的话，那个就 infinity。
它就会出现任何 dy dx 嘛，然后我就可以省去找这里的步骤，有没有这种可能？
有这种可能。
这样我可不可以这样子用
？OK， 你这样子的可能性只有一个，因为这个东西等于 dy d theta over dx d theta， 对不对？
对。
OK， 所以你这个肯定是0了嘛？这个
对。
后面上面一个就是0嘛。OK， 下面的话，如果它不是0的话，这个整个东西就要等于0了，对不对？假设如果这个东西只有一个可能性吧，它会去 infinity。
0 over infinity，
0 over 0。
0 over 0。
0 over 什么东西都是0嘛。
OK。
但是0 over 0的话就不知道发生什么事情。所以如果这个东西去 infinity， 你就可以
再找多一个 dx 的大。
你应该就可以 infer dx over d theta 要等于0。因为如果它不等于0的话，这个0 over。
如果我们拿到的是就是我们的题目啦，我就是算出来的时候，每个情况下它都没有这个 infinity 出现，意思就是讲，我可以不用去找 dx 的大，接下来就还是不可以。
现在讲你找这个跟你找这个就等于 instead of 这个你找这个吧，所以也是做2个步骤，不是？
也是做2个步骤。
一起嘛，然后可以用虚构来算。
咯，这样你都算出这个东西了，这样不是这个更快？你只要 sub point 进去就好了，然后你还要算这整个。你反正到后面都要 sub point 啊，你反正到底你都要 sub point 啊。但你只做这下面一个部分不是更快？你就做一行罢了，你还要做2个除在一起，对吗？
也是可以，
是不是？
可是我想知道有没有这种可能？
有可能，我刚才 reason 给你听啊，你听得懂吗？
听得懂，就是除非我拿到 infinity， 就是讲它是0 over 0，然后这个的话我要再 further check 这个东西。dy dx 和 infinity， 如果其他全部是 numbering 的话，意思是讲我
没有，你只有一种 number 你可以拿到吧？这个情况，你只可以拿到0吧？ 因为你已经知道你的 dy over dr 是零了，所以零 over
anything 是零。
anything 是零。
OK
OK， 你只可以拿到零吧？如果你拿到不是零的东西，你的这边就会就应该要出问题了。
OK，因为
它就是要
你
零
是找那个conjunct point 嘛，然后一个很好笑的东西啊，就我不是很知道为什么这个题目不可以用 test of divergence。
哪一题？
第一题。
第一题啊，可以用，你可以去算，但是你要知道一件事情，就是 n root of 一个 constant 是等于1，所以1减1是0哦，猜不到，猜不啊，
如果它等于零，不代表它考分。
对
但是如果它考分的话，一定是零。
对
如果你算到零，
对，不可以回头，回不到，
就刷回去这边找。
只有一个方向吧，来去。
稍微那个低。
可以，这样子我什么情况下我都可以显示 test of
哎，
divergence。
那个是第一个你要做的事情。
如
如果它不是等于0，它就 diverge 直接。
OK
现在这题有没有过？它不是等于0，它就 diverge。
OK，好的。
你的意思说就是在就是判断一个级数它都收敛的时候，都可以用那个 test for divergence 就这个通用步骤解题的时候。
第一个最容易解的东西。如果说那个 limit 太难解了，那可能就不要了啊，因为有时候有点难解。
老师，你这几道题有没有讲过？就是这几道题
没有讲过，我会发答案。
就期中考试会考吗？这种题
为什么用？
不会，
不会，
应该不会。
这个也
我希望不会。
你看了这个我讲啊，你绝对对的。
那这个会考吗？这个
不会
考。这3道都不会考是吗？
唉，所以我刚才就说，如果讲不会考的话，不要说你就不要看了，我会发答案。但是你不要
考完再看呀，真的是。
考完你也不用看了啦，我下一个阶段不会再考这个 chapter。
但是就我看情况，就是有些时候我会去看一下，因为
对，你不要看就不要看吧。但是如果有怎样，你不要怪我。
没关系的，这个主要是那个概率论实在复习内容实在太多了。
OK。但是 Taylor series 重点你要找 Taylor series 要找 interval of convergence 那些了 check and point 啊什么的。
那你这道题怎么讲？
那题，哎，不小心 skip 掉是这个题。啊，这你会发答案？
解释啦，
我全部会发。如果没有答案，你跟我投的，我会发。全部会发，全部。
一旦有一个 view 直接转 ID。
刚刚那个二项
不屌，这个
这道题
一旦有个 view 直接转。
他有时候他问题这种让你找这个麦克劳因这个指数的时候，
反正也是跟你们一起。
如果说这个就是空项写出来之后，你要写这么要选这种简洁形式，然后才能拿分。还是说，
但是如果你要上 radius of convergence，你肯定是肯定也不一定不一定的吧，不一定的，
简洁。对他这种题是不是这种都要写成这个 sigma 一个大 sigma 这种形式会拿分？
如果我找不到的话，我可以不写，我直接列是个形式，我加个 dot 加 dot 3个。
不要写，顶多也只有一个。
就比如说，就咋是不是就如果
从这样
的形式，
没有啦，我不知道，我是说 I mean 如果真的要给分的话，就写就写了，写，
不能就扣1分。
如果写错2分，
哎，你不要好像写一个啊，一下加3个洞，我不知道后面发生什么事情哦，这样的话。
可以。
你应该写后面发生什么事情哦，你要写。
谁要分这里谁要错2分？
哎呦，这样的话真的是会有这种意外发生，没有办法，真的没有办法。
反正如果只写这种合适的话，就是求分这种全部加起来的话，就最多扣1分是吧？
如果真的写不出来。
然后之前就是上节课好像你那个有道题，我看你过程好像有点奇怪，找一下在哪里？
他们是可以
就是你在也会比这个找一下，我感觉非常奇怪。